In this video for Cambridge Computer Science 9618, we're going to take a look at a recursion question that could show up on your paper 3 exam. Remember, your paper 4 exam is 100% programming, so if recursion shows up, it could be a programming question, or it could show up on your paper 3, and this walks through a paper 3 recursion question. So what is recursion? We need to know what that means so we can answer the question effectively. So recursion is simply a line of code inside a procedure or function that calls itself. Now, it keeps calling itself until it reaches what is known as its base case. The base case is the condition that allows it to finally exit. When the procedure or function is called inside itself, the current call is placed into a stack. And remember, stacks work on the first in, last out principle. So let's look at a question and how it works so we can master that paper 3 exam. So here's the question. This shows up on this is a former question from 9608. It says a recursive algorithm for the calculate function is defined as follows. So it gives us a function called calculate, has a parameter called number, which is a data type of integer that returns an integer. If number equals 0, then calculate becomes -10, else calculate becomes number times calculate number minus 1, and then that ends the function. So what is meant by a recursive algorithm? They just want to know, can we define what a recursive algorithm is? And it refers to a line of code where a procedure or function calls itself. Then for part 2, state the line number and calculate where the recursive call takes place. Where is it calling itself? Well, this is called calculate. Here we can see calculate becomes -10. That's not calling itself, that's assigning a value to calculate. Here, it calls itself. Calculate becomes number times calculate, then in parentheses, number minus 1. So that happens on line 06 or simply line 6. Now the question goes on to see if we can actually trace this out. So here we have a stack. We need to understand how recursion works so we can answer this question and know how it comes out to a final value. So it says the function is called with calculate 3. Drive run the function, complete the trace table below. So we'll do that in a minute. State the final value returned, show you're working. So we have a stack. Now the current call always goes onto the stack when the function calls itself. What does that mean? Well, let's take a look. So calculate 3. If number equals 0, number doesn't equal 0 because it's 3. So I skip over then, I go to the else, calculate equals or becomes number times calculate number minus 1. Well, the current number is 3. 3 minus 1 is 2. Now that it's called itself, it's going to say, you know what? We got to put calculate 3 on hold. We're going to put that into the stack and we're going to deal with calculate 2 because that's been called. So then, if number equals 0, it doesn't. Number right now is currently 2. Well, we skip over the then, we run this else. Calculate equals number times calculate 2 minus 1. It's calling itself. So where does calculate 2 go? It goes directly into the stack because now we got to deal with calculate 1. So we're on calculate 1. If number equals 0, it doesn't. Number equals 1, so I jump down to the else. Calculate equals number times calculate 1 minus 1. Well, that's calculate 0. So now we got to deal with that. So calculate 1 goes onto the stack. Now we're on calculate 0. So if number equals 0, it does because number is 0. So calculate becomes -10. That does not go into the stack because it was able to complete it. So now that we know calculate 0 is -10, we can answer calculate 1, which is -10 times 1. Well, if calculate 1 is -10, that's been solved. It's out of the stack. Well, calculate 1 is -10. What is -10 times 2? That's -20. We have solved calculate 2. Then we have -20 times 3, which is -60. Calculate 3 has been solved and our stack is empty. So now let's take a look at the trace table figure out how to fill this out so we can get full points for our working. In call number 1, what was the function call? That was calculate 3. Is number equal to 0? False. It's not equal to 0. So what does that return? That returns number times calculate 3 minus 1, which is 3 times calculate 2. So then call number 2 is referring to calculate 2. Does number equal 0? No. 2 doesn't equal 0. That's false. What does calculate 2 return? Well, it returns 2 times calculate 2 minus 1. So that calls calculate 1. So my third call is to calculate 1. Does 1 equal 0? That's false. What does calculate 1 return? It returns 1 times calculate 1 minus 1, which is 1 times calculate 0. Now my fourth and final call is calculate 0. Does number equal 0? Yes. I've reached what is called my base case, and that comes out to negative 10. Now that I have solved my base case, I have done what's called winding. It's now time to unwind. So when I work this out, I'm not going to start at the top. I'm going to move backwards line by line. So I know that calculate 0 is negative 10. That means I have 1 times negative 10, which is negative 10. That is what calculate 1 equals. Now that the computer knows what calculate 1 equals, which is negative 10, we can now solve calculate 2 because it was 2 times calculate 1. The computer knows that calculate 1 is now negative 10. So we do 2 times negative 10, that's negative 20. So now I know, or the computer knows, the value of calculate 2, which is negative 20, which allows the computer to now solve calculate 3, because it had 3 times calculate 2. Now that the computer knows the value of calculate 2, which is negative 20, we can do 3 times negative 20, which is negative 60, and that is the final value of the call to calculate 3 in this recursive function. Hope you guys found this video helpful. If you did, make sure to give it a thumbs up and subscribe to help the channel grow, and we'll see you guys in the next video.